So our goal here is to be able to flexibly convert between words and mathematical symbols. So given a context, we can write an equation that represents that. So write an equation for the scenario. 6 less than 4 times a number. So 6 less means that we're going to be subtracting 6. 4 times, we're multiplying here. And then we see this is, that's going to be an equal sign. So that's the subject of this. So we want to subtract 6. Okay, so, and we're going to do it 4 times a number. So I'm going to put that before it. So I'm going to do 4 times x, and that's going to equal 20. That's our equation, and that's all we're asked to do here. Okay, this next one, we're going to write an equation and solve this. So the temperature in Frostberry is -7 degrees Celsius. This is 18 degrees Celsius less than the temperature in Cold Spot. So find the temperature in Cold Spot. So we're given this temperature, and it says this. So this -7 degrees is, and then 18 degrees less. So we want to subtract that, okay, from this unknown temperature. So -7 is going to equal, and we're going to subtract 18 from the temperature in Cold Spot. X, we could use C for Cold Spot. Okay. And then we want to find the temperature in Cold Spot, so let's add 18 degrees to both sides. And then we get 11. So 11 degrees is the temperature in Cold Spot, so still cold. All right, the next one. To pass algebra, a student must have an average of at least 70 on 5 tests. In the first 4 tests, the student has scores of 75, 79, 64, and 71. What's the minimum score on the 5th test that would guarantee a student a passing grade in class? Okay, so again, we're reading the whole thing, and then we'll break it down a little bit. So first sentence, we're looking at averaging of an average of 70 on 5 tests. So what we're going to do is we're going to add 5 scores together, and then we'll divide it by 5, and we want this to equal 70. So in the next, so we have to know how to find an average. The next one, we're told what 4 of those scores are. So we have 75 plus 79 plus 64 plus 71, but I need a 5th score. I don't know that. If I don't know something, I'm going to use a variable for that. So that represents that one thing that I don't know. So when I add these all up, it'll be the easiest thing to do here. Okay, we're at 289. Okay. All right, I'm going to undo that division of 5, so I'm going to multiply each side by 5. And then I'll subtract the 289 from both sides, and so I get x is 61. So the student must score at least a 61. Okay, so it can be higher, but if it scores a 61, then we'll have an average of 70 on the test. So we do want to set up, we can't just average 4 of them and find out what the last one is. We do have to set up with thinking that we're averaging those 5 and just use that x for that unknown. Okay, so the next one, okay, this is a system of 2 equations because we'll have 2 unknowns. So let's read to see what's going on. During 1 year, Sarah invested $5,000 in 2 separate funds, one earning 2% and the other earning 5% annual interest. The interest Sarah earned was $205. How much money did she invest in each fund? So really, this kind of goes with 2 goals. One of setting up equations and the other one of solving this. So what we're looking at is in this last statement here, how much did she invest in each fund? So even as we see here the answers, this is, amount invested in the 2% fund. And this is really our amount invested in the 5% fund. So when we're describing this, we're talking about these quantities. We're not just saying 2%, 5%. Like, that doesn't describe them enough. So if we look at how much was invested in the 2% and how much was invested in the 5%, that should total up to 500 or 5,000. So we're just going to take x plus y equals 5,000. Then, looking at the interest, we have a total of $205 in interest. So to find the interest, we're changing that 2% to a decimal. So 2 divided by 100 is 0.02. Times the amount was invested will tell us how much interest we earn. Then plus 0.05 times y will also give us the interest. So these are our two equations that we have, and we're going to solve them. And you can choose how to solve them. I kind of like to use the elimination, but you could use substitution as well. So I'm going to multiply this by negative 0.02. So I get negative 0.02x minus 0.02y equals, let's see, 5,000 times this gives me a negative 100. I'm going to add those two equations. So the x's eliminate, and I get 0.03y equals 105. So then 105 divided by that 0.03. I get my y is 3,500. I could put that right here. This is a dollar amount. And then I know that both of these funds we're going to add up to $5,000. So I'm going to say x plus the 3,500 equals 5,000. So when I subtract that, I get 1,500. So $1,500 is invested at 2%, and $3,500 is invested at 5%. Okay, we're going to do one more problem in this. And again, this problem too is more of a setup and solve. So it's kind of breaching into two different standards here. So at one company, a level 1 engineer receives a salary of $56,000, and a level 2 engineer receives a salary of $68,000. The company has 8 level 1 engineers. Next year, it can afford to pay $472,000 for their salaries. Find how many of the engineers of the company can afford to promote to level 2. Okay, so I have these two things. I'm going to call them x and y. So x is really the number of, we'll say, level 1 engineers. And then y will be the number of level 2 engineers. So we're told a few things in here, okay? We're told the salaries of each, and then a total amount of salaries. So let's work with that for an equation. So we have 56,000, and then we're gonna, however many level 1 engineers we have, so we have to multiply by x, and then plus the 68,000 times how many level 2 engineers, and we want this to total to the 472. So we got one equation. The other thing we see here is that there's 8 level 1 engineers. So they're not looking to hire any more people. They're just looking to be able to promote some people. So they're still going to have 8 engineers. So if we look at the number of level 1 engineers plus the number of level 2 engineers, this will be 8. Okay, so then from here, we got our two equations. We know what those unknowns represent. We could use elimination or substitution. This time I'm going to use substitution to try something a little bit different. So I'm going to solve this other one. I'm going to subtract y from both sides. So x equals 8 minus y. And I'm going to plug that in for this x up here. So now I have 56,000 times 8 minus y equals 68,000. Plus 68,000, y equals 472,000. So let me distribute the 56,000. 40. 8. Okay, and so I'm going to subtract this 448,000 for both sides. And then I'm going to combine these two together too. So I get 24,000 over here. All right, so if I take the 24,000 and divide by the 12,000, I get 2 for y. Okay. So that means that y is the number of level 2 engineers we can afford to have 2 level 2 engineers, so 2 people will get a promotion. So the key to this is always to know what your unknowns represent. So if there's something that you don't know, use a symbol for that.